All right, 2.8 inverse functions. Here we go.
An inverse relation will undo a given relation. Every inverse relation can be found by
Switching.
each x and y value.
All right, so that's basically what we're going to be talking about the next couple days. All right, and the quicker you can get that, the better, because this is an inverse. What's an inverse? It's a switch in x and y. Everybody say it together. What's an inverse? It's a what? Switch in x and y. All right, we can basically be done with the lesson. However, it's got a lot of things involved with that. All right, keep going.
In some situations, this process is intuitive, but other times this may not be as obvious. In these cases, it is important that we understand the
Concept.
of inverse relations as they will help us tackle a variety of problems. Let's look at this numerically, tables, graphically, pictures, and analytically, equations.
All right, so example 1, we're going to find the inverse relation of the given table. So again, what's an inverse? It's a what? Switch in x and y. And so if my first ordered pair is 1, -1, what's my inverse's ordered pair? -1, 1. And then if my next ordered pair is 3, 2, what's my next ordered pair? Or my inverse's ordered pair? 2, 3. And then if I have 4, 0, what's my inverse? 0, 4. And then if my function is 6, 2, my inverse is 2, 6. All right, keep going. You're doing great.
The original table is, a function because each
X value,
has exactly one.
Y value,
However, the inverse is
not.
a function because
The X value has multiple outputs. I have a juicer at home. And if I put in an orange, what does it make? Orange juice. So then I put in another orange, and what does it make? Orange juice. I put in another orange, what does it make? You guys are getting the idea. This is great. And so what if I put an orange in my juicer and I got apple juice?
You'd have a problem.
I'd have a problem, wouldn't I? Because each individual input should have what? One output. So if we look at this thing, I go 1, -1, 3, 2, 4, 0, 6, 2. Each unique input is getting an output. Now, are these two the same output? Yeah, that's okay though. However, if I look at this inverse function, what's happening? I put in 2 and I popped out 3. And then I put in 2 and I popped out 6. Well, what happened? Is that a function anymore? No. All right. So let's talk about things graphically now. All right. Again, what's an inverse? It's a what?
Switch.
It's a switch in x and y. And so I'm going to go ordered pair style on this. Okay. So if this is my function, this ordered pair would be what? -2, -1. And so my inverse's ordered pair would be what? -1, comma, -2. And so now I have -1, -2. And so we're going to do it again. So what's my function's ordered pair on that little dot? -1, comma, 2. You guys with me? All right, and so then what's my inverse's ordered pair? 2, -1. And so now I have 2, -1. And then if I keep going, my next ordered pair would be what? 2, 1. And so my inverse's ordered pair would be 1, 2. And so now I would start looking like that. And so then my function's ordered pair would be what? 4, 3. And so my inverse's ordered pair would be 3, 4. Now, let's talk about it further. Okay, so that would be the graph of my inverse function. All right. And so in part B, in this one, is the original function, or is the original relation a function? So if I look at my black/red one, is this a function? Is that a function? Yeah. Why? Why is that a function? So my original is a function because it passes what? The what kind of line test? The vertical line test. All right. You don't have any cheaters going on. All right, and so the original is a function because it passed the vertical line test. Now let's talk about our inverse. Is the inverse a function or not? So when I go along this one, is my inverse a function or not? No, because in between 1 and 2, how many outputs does it have? It has how many? 3. All right, and so my inverse is not a function. All right. All right. So the graphs of inverse functions are reflections. Over the line, what? Y equals x. So it's y equals x because what's an inverse? It's a switch in what? X and y. All right? And the quicker we can get that, the better we'll be. Because it's a switch in x and y, so if it's reflected over the line y equals x, there we go. All right? All right, so now we're going to find inverses of these. And so back in Francie Pience's class, this was how you found inverses last year. And again, what's an inverse? It's a what? A switch in x and y. And so most of the time you guys spent last year with inverse functions, this is what you did. All right, and so if I have my function equals 3x minus 7, the first thing we're going to do is we're going to switch our x and y. And so now I'd end up with x equals 3y minus 7. The next step that you guys did last year, which was good, is you solve for y. Now, I think you guys can do these two steps in our head. And so how do we solve for y? First we do what? We add 7, then what? Divide by 3. So you end up getting y equals the quantity x plus 7 over 3. However, the inverse function is written not just as y, but inverse of x. So f inverse of x. And so I need to replace this y with f inverse of x. And I'm left with x plus 7 over 3. Right? That's what you guys were accustomed to doing last year. So that's kind of what you guys were familiar with last year. And so now we're going to deal with rational functions, which have multiple x values. But the steps are still going to be the same. All right? So our first step is still going to be switch x and y. We're going to solve for y, and then we're going to replace y with f inverse. That's really what we're going to be doing. We just have multiple x's now. All right? So let's do it. So let's switch our x and y. So now I'd end up with x equals y minus 2 over y plus 3. I need to start solving for y. So eventually I need to isolate it. But how many y's do I have now? 2 of them. All right? And so how do I get the thing off the denominator? How do I get y plus 3 off the denominator? I multiply by y plus 3. And so now I multiply. So now I have x times the quantity, y plus 3, is equal to y minus 2. And because I need to get y's together, my next step, I need to distribute this x. All right? And so now I have xy plus 3x is equal to y minus 2. Now, my next step to get y by itself is to get the y's together and everything else on the other side. All right? And so what I need to do is I need to bring this y over here. Well, I guess it doesn't have to be that way, but I'm going to bring my y's to my left. I don't know. And then I'm going to put 3x over there. All right? And so now I'd end up with xy minus y is equal to negative 3x and then minus 2. So from there, how could I start isolating y? I could factor out a y. And so when I factor out a y on my left side, I'm left with what? Y times x minus 1. And that's equal to negative 3x minus 2. And so then my last step, or actually my second to last step, is to divide by what? X minus y. And so now I have y is equal to negative 3x minus 2 over x minus 1. All right? And so I don't have an inverse yet. And so what do I need to replace this y with? F inverse of x, which would be equal to this negative 3x minus 2 over x minus 1. So on this next one, I have this, but what's my first step? I think we can skip a couple steps on this one. So what's my first step? Switch x and y. And so now I'd end up with x equals 2y plus 1 over y minus 3. All right, so now I need to start solving for y, but I got two of them. So what do I need to do first? Multiply by y minus 3. Now, I made 2 steps out of it, but I think you guys are smart enough. So I'm going to distribute right away. So now I end up out with having what? xy minus 3x. All right, so the first example I showed all my steps. This one, I think you guys are good enough to like break them down a little bit. And so now I need to get my y's on one side and my x and everything else on the other. And so I'm personally going to bring my y over here, but you don't have to. So then I'm going to move that guy over there. And so now I'd end up with what? xy minus 2y is equal to 3x plus 1. And so then what can I factor out? I need to factor out a what? A y. And so now I have y times x minus 2 is equal to 3x plus 1. And we need to divide by what? X minus 2. And then we're going to replace y with what? F inverse. All right, so now we're going to say F inverse, or oh, it's not F this time. What is it? It's G. And so this is really G inverse of x is equal to 3x plus 1 over x minus 2. All right. So again, what's an inverse? It's a what? Switch of x and y. All right. And so there's kind of part one of part one. We'll do much more with inverse.